Okay, so
Don't say anything yet.
I'm going to say so much right now.
Still trying to do stuff. Okay.
The square root of x minus 1. So C is a new one for us. We're going to talk about that, okay? But the square root of x minus 1 starts at 1, and it's like half a parabola, but sideways, like that. And I have the projector frozen. Blah. Okay. If we rotate, if we're going out to x equals 10, that's out here. Cool? And even though we don't need it right away, if x is 10, what's the y value going to be? 3. Okay? If we want the area, remember we always say the area is just a bunch of rectangles in there, and it's always top minus bottom. And we're going to integrate from left to right since we're doing it in terms of x. So you can think we're going to put all these little blue rectangles in here that are infinitely thin. Okay, I'm drawing 2 of them for some reason. So it should just be the integral from 1 to 10 of the square root of x minus 1 minus the bottom, which is 0. You do not need to put that, but I think it's just easy to get into the habit of doing top minus bottom. X-axis is 0. And you integrate that. Cool? You could do this by hand, but you're allowed to have a calculator for this one because it's a number 1. What's the answer?
It's 18.0025.
18.0000.
6 zeros.
Seriously.
I think.
Anybody else get that?
Yeah.
So just 18,
Yeah.
I guess, is what we'd say for that one, okay? That's A. That one should be easy for us, hopefully. Okay, now we got the whole shape down. B, to rotate around the line y equals 3. I'm going to draw this again. Here's our shape starting at 1, going out like this, all the way to 10. And y equals 3 is this line. I'll do a different color just because I can. Is this line right here. Okay with that? So all we need to do is find big R and little r. We're going to use our formula as always for rotations. Pi times the integral big R squared little r squared dx. And we're going from x value 1 to x value 10. So big R, remember we said, is take your pencil, put it on the x-axis. Not the x-axis, the axis you're rotating around. Draw to the outside of your shape, which means you're going to go through it once and hit the outside side. Okay? No matter where you do it, what's the top of every single one of these? 3, and the bottom is 0. So big R is just 3 minus 0. So this integral becomes pi times the integral from 1 to 10 of 3 minus 0, that's just 3, squared, minus, now we need a little r. Well, if we do the same thing, except now for little r, you just hit the shape one time. You hit the inside of it. That's going to be right there. And you can see, no matter where you do it, you're always hitting this same blue curve, which is square root x minus 1. So the top of that is 3, and the bottom of it is the square root of x minus 1. So little r is 3 minus the square root of x minus 1 squared dx. Any questions on that one? Yeah, blah, blah.
Why is that big R?
Big R? Because, well, big R obviously has to be the largest R, the bigger one. And the way you find it is, again, you put your pencil on the axis where you're rotating around. That's 3 for us in this case. And you draw to the very outside of the shape from that line. That's right there. Does that make sense? Yeah, man. Not like the top of the shape or the bottom of the shape. That doesn't matter because it depends on what the line you're rotating around is. You draw to the outside of it from the line you're rotating around. Okay? That'll always be big R. If that ever changes, now it doesn't in this case, then you need more than one integral. You're not going to see a lot of that on the AP exam. Okay. Yeah. So there will always be a big R and a little r if your shape is going to have a hole in the center. Do you guys see if we rotate this area around that axis, there's going to be kind of like a little hole in the center. It's going to make like a cone kind of thing. If we take, oh, come on now. If we take this area right here and we rotate it around, what's the outside going to look like?
Well, technically, I don't even know if that will be a hole.
If we rotate it around, the outside is going to look like what shape here? It looks something like, that's what the outside is going to look like. That's a terrible drawing.
Not even.
Yes, it is with the outside. The outside is a straight line. Look at this. The outside is just this line right here. If you rotate that around, it's going to create just like a big old cylinder looking thing. But the inside is going to have
This little.
this weird looking like hole inside of it, like this. That makes sense? If your solid is going to have a hole in the center, there's a little r. That's it. There's always a big R. There's always an outside of the shape. There might not be an inside if there is no little r. Okay, there's no hole in the center. Hello, Anthony. Cool? All right. Let's talk about C for a second here, gang.
That's what it sounds like if you go.
Oh, yeah. What's the answer to this, gang? 67.5? 40.5.
Wait, let me do this. I got it.
Okay.
No, but I got 67 point something before.
Okay, Google. Calc AB, free response, 2007. It does say Calc E. You think that's what I want? Okay, Google. Calculus AB, 2007, free response. AP Calculus exam. Are you kidding me? Okay, Google. Calculus AB 2007 free response.
I got 67.
Very good.
Multiplied by pi.
This is not 2007?
I got 212.
This is the worst video I've ever made.
Wait, what motive? I'm in
2004
grade.
Form B. What's up?
I got 212. What the hell?
Okay, I got, yeah.
Okay. All right. I should have looked this up again.
Oh, okay. I thought I was wrong. Okay, I knew I was right. I'm always right.
Oh my gosh. Okay.
I got a laptop and they have the keyboard where you write on it and then it turns it into words.
It's super cool. I love it. What kind of laptop is it?
It's a Dell.
What am I doing? Did we do that? What year are we doing here? Hold on. Pause this. Okay. The answer is 212.058. Oh my gosh. 212.058. Let's all simmer. Simmer. Look, I know we're all excited. It's fun to play with the calculator. Let's talk about the third part of this. We have not done one of these yet, so let's see what's going to happen, okay? Oh my lord. The vertical line x equals 10. Let's check this out. Woohoo! Are you ready? I'm going to redraw the shape. Everyone should be paying attention to this most important topic for your life. Okay. Now we're rotating around a vertical line. X equals 10 is a vertical line. That's over here. Cool? It's a dotted line that's drawn. It's the end of the shape. Can you imagine when we rotate this, is there going to be a hole in the center? There's not going to be a hole because it's flush against the axis. So this doesn't have a little r. All right? That's fine. I just don't want you guys to get confused. It does not have a little r in this case. But there is a big key difference for us in this kind of question. We always rotate around horizontal lines, right? And we find big R, little r, do dx, all that good stuff. We are going to handle this similarly to how we start off around a horizontal line. We're going to put our pencil on the axis we're rotating around, and we're going to draw perpendicularly to the outside of the shape. So perpendicular from a vertical line is horizontal, semi-horizontal, is horizontal.
What does perpendicular mean?
It means it makes a 90-degree angle with that axis we're rotating around. Do you guys see that? Do you see that no matter where I put my pencil on this axis, if I go perpendicular out to the shape, I always hit the same function? Okay? Now, here's the problem with this. We are going to be rotating this little red line is supposed to be like our little rectangle that we are rotating around to create that cylinder. Like there's going to be a bunch of cylinders. So if we rotate this around, something like that, it's going to make a really tiny thin cylinder. Okay? The volume of the cylinder is still going to be pi r squared h. But normally we're rotating around a horizontal line and we have like kind of vertical cylinders. Here we have a horizontal cylinder. Which variable am I crushing down to make that cylinder infinitely thin? The radius. I'm still crushing down the height, but the height now is the y value. So h is becoming dy. We're crushing the h down still, but now it's dy because it's changed. Okay? So now what that means is we still need the radius, but the radius isn't top minus bottom. It's going to be the right side minus the left side. Okay? But the fact that we have to use a dy means that we have to have all of our variables in this integral be y's. Like this is a very common mistake. Kids will say the radius is, what's the right-hand side of all these radii I draw? What is this?
10.
That's 10, and this over here should be root x minus 1, right? A very common mistake, this is wrong, is for students to put 10 minus the square root of x minus 1. Okay? That looks correct, right? That's right minus left. But we need this to be in terms of y. So the trick is you come up here to this graph, which is y equals, oh, my pen stopped working. It's y equals the square root of x minus 1, and you solve it for x so that we have y's in the equation. Okay? So right now we have y equals the square root of x minus 1. If you solve that for x, you get that x is equal to y squared plus 1. So the radius isn't, you with me here? Omar, I see you're with me by laying your head down. Excellent. The radius isn't 10 minus root x minus 1. It's 10 minus y squared plus 1. It has to be in terms of y. That's big R. So that's going to go here. 10 minus y squared plus 1 squared. The pi is still there, and we're still integrating it. We don't need a little r in this case because, check it out, this is how you always know whether or not you need a little r or not. If you put your pencil on this axis, like I did, and we draw it to the outside of the shape, how many times have I hit the shape? Once or twice? Just one time. There's only one radius. If I hit it 2 times, then there's got to be 2 radii. One's big and one's small. Make sense? So, that's our answer right there, except we have to tell it where to integrate from. Normally we tell it from left to right. In this case, that would be from 1 to 10, right? But our variable we're looking at is y, not x now. So we have to tell it what y values to go through. What's the lowest y value?
0.
And the highest is 0 to 3. Because we know we're going to this point right here, which we know is x equals 10, right?
Yeah.
If x is 10 and we're on this curve, y has to be 3. Does that make sense?
Yeah.
Something else you can do, if this is confusing to you and this will work, is you can take, check this out, if you want to rotate something around a vertical line, x equals 10, you can basically switch everything from x to y. You can trade places with everything and then just do around a horizontal line. It changes the picture, but it's the same exact volume. Okay, so for instance, I can make this y equals 10. So we're kind of turning the picture sideways. I can make that y equals 10, but then I wouldn't have a square root function, which is, it'd still have a parabola. I'd have this side right here. It would look like that. Okay, and when I say switch x and y, you still need to switch the x and y in that equation. So it was y equals root x minus 1. That's a terrible y. You're going to switch that to x equals root y minus 1 and just solve that for y. It just creates a whole new picture, okay? So y, if we solve for y here, it's the same math we just did. If we solve for y, we're going to get that y is x squared plus 1. So if you feel better about doing it like that, now we are going from right to left, and we're using x's. And you can see that our radii are right there. It's still the same radius, 10 minus x squared plus 1. Okay? But sometimes kids like to look at it all in terms of x instead of y. So it's the same exact math. I don't care how you do it. We're good? And then you got to put this into your calculator to get an answer. Anybody go that far? You got it correct. 407.150. Please remember, when you're putting this into a calculator, even though there are y's in your integral, you're just going to put the actual, you're going to put x's in. That's all. This was, even though I looked it up wrong like 4 times in a row, 2004 Form B, number 1. Okay. How do you get all the points for it? Like, what are the scoring guidelines?
Where are the parts where we have to write stuff?
So for these questions, there's not a lot of writing or explaining. Okay? All you really need to do, check this out, do not just put the answer. Okay? That's wrong. This first part, A, that area question was worth 3 points. But you've got to have the correct limits. That's the numbers on the top and the bottom of the integral. Okay? You have to have the correct integrand. That's what's inside the integral. And you have to have the correct answer. So our rule is, on the AP exam, if you're allowed to use a calculator and it's a free response question, anytime you do an integral in the calculator, write down the integral you did on the paper. Does that make sense? If you just put down your answer, the most you can get is 1 point. If you just put down your answer and it's the wrong answer, you get 0 points. But let's say you put down this integral here, which is correct, but you integrated from 0 to 10 or something weird like that. You would lose points for those limits, but you'd still get the points for the integrand, and you might get points for that answer. I'm not 100% sure about that, to be honest.
Why don't they give you that, like, access?
Well,
What you need to have?
because you're supposed to know, man. Well, do you think during your driver's test they're going to be like, don't run through that red light? No, man, no. You're like, this is your full on, calculus license testing. All right. I don't know why I'm so recording.